see, look at this question. d4 minus 81y equal to 0. So see, right hand side is 0. We will first factorize it. So it will be d square plus 9. This is d square minus 9 y equal to 0, or this will be d plus 3i, and this is d minus 3i, d plus 3 y equal to 0. So I can write CF as the only solution is CF. There is no PI because right hand side is 0. So y is equal to C1 e to the power 3x, C2 e to the power minus 3x, and then you have C3 cos 3x plus C4 sin 3x. This is going to be the solution. This is 3i plus minus 3i is the complex root, and these are simple root 3i and minus 3x. So this is a solution. Let's take the next question. So look at this question. d cube minus 4d square plus 5d minus 2 equal to 2y equal to 0. We have to factorize it. See, when you want to factorize it, see the last term, this is minus 2. So try, you know the factor theorem. If suppose you have a polynomial fx, right? So if I put say x equal to a and this is 0, if this is the equation, this side is a polynomial. See, if I put x equal to a and this becomes 0, fx becomes 0, then fa becomes 0. If you have a polynomial fx and if you put a, fa becomes 0, then x minus a is the factor of fx. X minus a is the factor of fx. Alright. So see here, this is minus 2. So you try 1 plus 1 plus 1 minus 1, you try plus 2 minus 2. You try to put it over here and see whether this becomes 0 or not. So if I put plus 1, this will be 5 plus 1 6, and 4 plus 2 6. So obviously if I put d equal to 1, it will be 0. It means d minus 1 is the factor. So try to construct this factor d cube. We have to take d minus 1. So this will be d square minus 3d square plus 3d 2d minus y equal to 0. All this is d square d minus 1 y equal to 0. So this comes as d square plus 2 y equal to 0. So it's d minus 1 d minus 2. So you have 1 2 1 1 1. These are repeated roots. So your equation is going to be c1 plus c2x e to the power x and c3 e to the power 2x. So these are the cases when, see, this is the equation, differential equation with constant coefficient. So these are the cases when x is 0. Now let's solve the differential equation where x is not 0, x is some function. Let's see how we go for finding those. There also you have to first find CF. CF is the solution of f dy equal to 0. CF is the solution of this equation. Equate x to 0, find the solution, that is the CF, that is called complementary function, and then you solve 1 by fd x, that's called particular integral, and both will form the complete solution. Complete solution will be complementary function, which is the solution of f dy equal to 0, and pi is this one by fd operator x, right? So this together will give you the complete solution, right? I explained to why we go for finding CF in the last previous videos. So this is how we find the solution. So I'll take different x. I've already told you how to find CF. For that you have to factorize like this. And now we'll concentrate on how to find particular integral, right? CF, for every equation, CF will be found in this manner only. And here we will concentrate on how to find particular integral. So first of all, I'll go for some general method of finding pi. General method of finding pi. Right. Let's see the general method of finding pi. See, this is your equation x. So you factorize it, d minus alpha 1, d minus alpha 2, d minus alpha n, y equal to x. Then for pi, what you have to do is you should d minus alpha 1, d minus alpha 2, d minus alpha n, x. So let me first tell you, we'll operate it one by one. We'll operate it d minus alpha n minus 1. So let's operate first d minus alpha n, and we have to operate it on x. So I'll tell you how to find this, and similarly you can keep on operating 1 minus d minus alpha 1, alpha n minus 1, and so on, right? So let's first discuss how do I find this one. Let's say how we find 1 minus 1 by d minus alpha and x. Suppose this is equal to y. So this is d minus alpha and y equal to x. That is dy by dx equal to x. So integrating factor is e to the power minus alpha and x, right? So your y into is equal to xe plus some constant. So you don't go for the constant, this will appear in the CF, right? So y comes out to be e to the power alpha and x integral see this part will appear in complementary function, so you don't have to consider this part. So it will be just 1 by alpha and x is equal to e alpha and x e to the power dx. This will be pi. This part will go into complementary function. I discussed in the last lecture also. So this is the formula. You remember this. You remember this. Your alpha n can be positive, it can be negative also. So you remember this formula, right? If I write 1 by d plus alpha n, then the formula is not different. Just you can replace it here by c alpha n x e to the power dx, like this. All right. So we have to solve this, right? Your complementary function will be the solution of this equation, right? So complementary function comes out to be c1 sin ax and c2 cos ax. The particular integral is going to be d square plus a square sec ax. So this can be written as I can write this as d plus ai d minus ai sec ax. So this can be written as 2ai, and this will be and d minus ai so this comes to be 2 and 1 upon d minus ai sec ax, sorry, this is sec ax. So I'll find one by one this d minus ai sec ax is going to be e to the power IAX and sec AX e to the power minus IAX dx. So this comes out to be e to the power IAX 1 upon cos AX, and this is cos AX I sin AX dx. So this is IAX, this is 1 minus I tan AX dx, or this is IAX x minus I upon A log sec AX. Alright. Similarly, if I find d plus AI sec AX, that will come as e to the power minus IAX x by x plus I by A log, if I replace A with minus A over here also, then sec minus AX is sec AX only. Sec X is odd even function, right? So this will be the answer. So if I take the difference, this comes out to be 1 by 2 AI, and this will come as, this will be, if I take the difference, this is going to be x EIAX minus e to the power minus IX minus I by A log sec AX like this. So this comes out to be 1 by A x into EIAX upon 2i, and this will come as 1 by 2a, or you can say I will cancel out, so this will be 1 upon a square sec x, I take 2 here, e to the power IX upon 2, right? So this will come as 1 upon AX sin AX. This is sin AX, and 1 by A square log sec AX, and this is separate, cos AX. Alright, so this is going to be a particular integral. This is Pi. So your complete solution is going to be CF plus Pi, that is C1, I don't know what I have written. This will be C1 sin X plus C2 cos AX plus 1 by A x sin X 1 by A square and log sec X, right? This is going to be the complete solution. All right, but then this method is very complicated. This will be used at the last resort, right? When no method is working, you can use this. We'll have some shortcut method which will be applicable for some special kind of function like exponential function, trigonometric function. We'll have different methods. We'll have a special method which will be suited for different functions. So first of all, we'll start with